Now let's talk about classifying polynomials. First, to be able to classify, we need to decide whether or not an expression is a polynomial. And basically, to decide that, we have to pass a series of tests. And the way you pass them is by answering no to everything. So, to be a polynomial, we must answer no to all of these questions. First, are there any variables in the exponent? Second, are there any variables in the denominator? Are there any variables in the denominator? Third, are there any negative exponents on a variable? Or any fraction or decimal exponents? On a variable. If you can say no to each of those questions, then it is in fact a polynomial. Once we determine that something is a polynomial, we can take a step further and classify that polynomial by the number of terms. So if you decide that it is a polynomial and it only has one term, we can classify that as a monomial. If it has two terms, we can classify it further and call it a binomial. If it has three terms, that would be a trinomial. And lastly, if it has four or more terms, we cannot classify it any further. We don't have an exact name for it, so we will just leave it as polynomial. Okay, the important distinction here is that if you have a monomial, it's still a polynomial, it's just a more specific type of polynomial. Same idea with binomials, that's just a more specific type of polynomial. Now, example A gives us a few different expressions where we are going to decide whether or not it's a polynomial. And if it is, we're going to combine like terms if that's possible and then determine how many terms it has in order to classify it further. So starting with A, we ask ourselves, do we have any variables in the exponent? No. Are there any negatives in the exponent? Yes. As soon as you have a yes to one of those answers, you can stop because you know it is not a polynomial. Okay, and our reason is we have that negative exponent attached to x. Part B, we don't have any negative exponents. We don't have any x's in the denominator or fraction exponents, but we do have a variable in the exponent. We've got an x in the exponent, and that is not allowed. So we can say no. We have an x in the exponent. Moving on to C, we don't have any negative exponents or fractional exponents or variables in the exponent, but we do have an x in the denominator. So we would have to answer yes to that question, which means that it is not a function. D, 3x plus 1 plus 2x. So as we run ourselves through our 4 questions, are there any variables in the exponent? No. Are there any variables in the denominator? No. Any negative exponents? No. Any fractional or decimal exponents? No. So it is a polynomial. It passed the test. Okay, but we can actually simplify that expression. 3x plus 1 plus 2x has like terms. The 3x and the 2x we can combine to make 5x plus 1. And now we can classify that based off the number of terms. It has 2 terms, which makes that a binomial. Part E, we do not have any variables in the exponent, no variables in the denominator, no negative exponents, and no fraction exponents. So this, again, would pass the test. So we can say yes, that it is a polynomial. And when we look at our 2 terms, x squared and x to the 10th are not like terms, so we can't simplify that at all. We will just leave it as x squared minus x to the 10th, which once again has 2 terms, which would classify us as a binomial. Our last part here, F, negative 2x to the 3rd times 3x to the 2nd. Going through our test, any variables in the exponent? No. Any variables in the denominator? No. Any negative exponents? No. Any fraction exponents? No. So we do know that it is a polynomial. Then we need to decide whether we can simplify that or not. Well, here we are multiplying, and we can multiply those 2 terms. Negative 2 times 3 gives us negative 6. And when we multiply x to the 3rd times x squared, think about adding our exponents. 3x's plus 2x's will give us 5x's. Now we can classify that on the number of terms, and we just have 1 term, so that is a monomial. Now go ahead and go through the guided practice on your own, and when you are ready, watch the next video to check your work.